Today we will start with the introduction of the topic of polynomial regression, and we will see that how and when the polynomial regression is going to be applied and how to create a polynomial regression, and we will also going to see one example on that how polynomial regression solves the problem of prediction. And we will see that the polynomial regression, the equation, how to develop the equation, and this we are going to solve with the help of some sample data. So let's start with today's topic. So as we already know that regression is a technique where we are trying to find out the relationship between the variables, right? Now the variables, they are of two types. One is called as the dependent variable, and the other one is called as an independent variable. So when we talk about the dependent variable, the dependent variable is the one which is dependent on the other variable, and we are trying to predict the value of this dependent variable with the help of the independent variable. So most of the time this dependent variable is going to be indicated with the help of letter y. So we are using a small case y to denote this dependent variable. Then we have independent variable, and this independent variable we mostly denoted with the help of x. So when we are being given the data set with us, the columns or the features or the attributes, they are normally denoted by the variable x. So we can have x1, x2, x3 if there are three different attributes or three different features in the given data set, and from those x's we are trying to predict the value of the y variable, which is dependent on the attributes or the dependent or the independent variables, right? So we already have seen in previous lecture that how the linear regression model works and how we can create a linear regression model or its equation from the given data set. Now today we will start with the polynomial regression. So before going into what polynomial regression is, we need to first find out that what is the need of polynomial regression. So we already know that when the data has given to us, we have to see that what kind of relationship exists between the independent and dependent variable. So if the relationship between the dependent and the independent variable is linear, right? Linear regression model is most suited in that scenario, and for such scenarios or for such applications where we are sure that the relationship between the dependent and independent variable is linear, we can create a linear regression model for doing the future predictions. Now, what happens if the data is not showing any linear relationship with respect to the variables it has? So now, for example, if I have some data set where the relationship with the dependent and independent variable is like, for example, it is not kind of linear, right? So we are going to have, for example, this type of data set with us, and as you can see that nobody can stop us from fitting a straight line over this. So of course we can create a linear regression model for this type of data which is not necessarily following the linear relationship. But the problem is, as you can see visually from here, that most of the points they are drifted apart from this regression line or this regression model, which means that if we are trying to create a linear regression model for some data which is not following a linear relationship, then the prediction errors will be larger in such models, right? So now what to do in this scenario? So to solve this problem, we have two way outs. The first one is that we can transform the non-linear data into a linear representation, and then we can fit, as usually, a linear regression model over it, right? So in this approach, what I'm going to do, that I'm going to perform one extra step where I'm converting my non-linear data to a linear representation, right? And once this is done, now the data has already transformed in the linear domain, and then we can create a linear regression model, and we can do the prediction by using this linear regression model. And of course, the prediction error is now going to be minimized, because we already have converted the data from non-linear to linear representation. The another way is that we can choose or fit a non-linear regression model, which is specifically built for non-linear data, and through this model we can try to do the predictions for future patterns. So now, out of these two approaches which we have, in the first case we are transforming the data set itself, and again there could be problems, and this approach becomes complex, because based on the data we need to select a suitable transformation function which can transform my data as per my own requirement, right? So the most straightforward choice here is that we can use a non-linear regression model, which is quite inherent and seems natural to us when we are finding out the choices for us. So we will take the second approach here, where we are going to create some non-linear regression model, and this figure can tell you that what happens if the data is having some sort of specific spread. So in the first spread, you can see that your data is almost having a linear relationship. So it is okay if I use straight line to fit over this data, and this is going to cover most of the points here through this straight line function. Now suppose if the spread is like this, and what if I'm trying to fit here a linear regression model? So this LR model, as you can see, as compared to this quadratic curve, that the LR curve is not even passing through the maximum number of points. Rather, it is only passing or representing a few number of points from the data set. While if I talk about this curve is actually going through almost all the points, and it is covering or capturing the trend of the data. So you can see here the trend of the data in this case is kind of a curve, and by using this curve, and by using this curve, okay, we can best represent this type of data distribution. So we are going to capture this kind of spread with the help of polynomial regression. So when we talk about the polynomial regression, we are indeed going to use some sort of polynomial function to represent our model. And the polynomial regression model, first of all, it can handle the nonlinear relationship which exists between the data variables. And for representing this nonlinear relationship, the regression model here, it actually uses a nth degree polynomial, right? So by having a different degree of polynomial, we can represent the data trend with a certain level of curvilinearity. So it can also handle different levels of curvilinearity, how much curve or how much curvy the pattern or the line or the model is going to be with the help of this degree of polynomial, right? So if we already know that my data, if I visualize it or plot it, and I can see that my data is not linear, in a sense, then what I can see next is whether it is following a quadratic, spread, or it is following, a cubic spread, like that. And based on this intuition, I can, choose to fit or create a polynomial regression model here with a degree of 2 or 3. So if I see that it is a quadratic, spread, then I can go for a polynomial with degree 2. And if I can see that there is a cubic relationship between the x and y variables, then I can go for a polynomial with a degree of 3. So as you can see in this image that this is the curve which we have fitted over the given data points, and based on the spread of this data set, I can see that I can fit a polynomial with degree 2 here. You already know that what we mean by a polynomial of degree 2. The equation is y is equal to ax square plus bx plus c. So I mean, changing the degree of the polynomial, we can, change the shape and appearance of the curve. And for example, if I want to, create a model which is having a degree of 2 for a polynomial regression, then we can easily do it for a given data set. So for example, here I can see that the data set given to me is one independent variable and one dependent variable. So x is my independent variable and y is my dependent variable, right? And we can see from here that the values of y, they are nothing but the squares of x. So 1 square leads to 1, 2 square gives us 4, 3 square gives us 9, and this is 8. So this is almost closer to the square, which is 9, square of 3, which is 9, and 4 square equals 16, then 5 square equals 25, and this is much closer to what we have, right? So now how we are going to create a polynomial regression model for this given data set. So we want to fit this kind of polynomial over the data set here. And how to do it? So to do it, what I need to do, that I need to first find out the value of these coefficients. And as you can see here that we are having 3 different coefficients, the b0, b1 and b2. So I have 3 coefficients, b0, b1 and b2, and I need to know the value of these 3 coefficients to know my equation of polynomial regression. And once I know the equation, then I can put simply the value of x, some new observation or some new value of x which is not already present in the data set, and for that I can find out the value of this y, right? Now the first problem here is to find out the value of the coefficients b0, b1 and b2. How we are going to find it out? So for that, there is one equation which is, for example, if I'm representing this B matrix as A. So for example, I can say that this is my matrix A, right? So to find out this matrix, which is consisting of all the 3 coefficients A represented by A, I need to use this equation, which is X transpose multiplied by B. Now, how to create this X matrix and this B matrix? So we are going to create it like this. The X matrix is represented like this. So here the first element here is, for example, n. N is nothing but the number of observations that we have for our data set. And in this case, you know that, for example, we are having 5 observations or rows here. So n is equal to actually 5 here. So we are keeping the n. Then we have to find out the sum of x values. We have to find out sum of x square. Then the next element or the next row element will be sum x square, sum x cube, sum x square, sum x cube, sum x raised to the power 4, like this. And the B matrix that we have to find out, we can find it out like this. So we have to find out summation of y, then summation of x multiplied by, and summation of x square multiplied by y. Now, how to calculate all these values? So we are going to use a tabular method here, and with the help of this tabular method, we can find out the value of different elements of x vector and b vector, or this matrix, right? So we have simply written the x and y as the first two columns from the data set here, and what you are seeing here, this row is actually the sum of this particular column. So you can see that here this 15 is nothing but this is the summation of x, right? Similarly, this value, this is summation of y. Now we have created more number of columns so that we are able to find out all these values from here. And you can see from here that what more values I need to calculate is that I need to find out as x square, I need to find out x cube and x raised to the power 4. And then I need to find out x and y, then x square y. Okay, so we have created these many columns here, and we have calculated, for example, this xy, we have simply calculated by multiplying these two columns, and simply we are getting these values, and then finally we have summed it. So this is nothing but summation of xy that we are getting at the end of this column. Similarly, to find out the x square, we have simply calculated the square of this column x, and similarly we have calculated all other values of all other columns, and then finally we are summing all these. So now this comes to summation of x square, this is summation x square y, this is summation x cube, this is summation x raised to the power 4. Now once all these values are with us, we can create our matrices like this. So the first thing I'm going to put here as my x will be 5, the number of observations. Then I need to find out the value of summation x. So summation x I can find out from here. So you can see it is 15, then summation x, then summation of y is 56. So now you are putting these values. So you can see here this will be 15, and sum x square is 55, so you are keeping it 55 like this, and these are repeated only 55. Now you have to find out summation x cube. So summation x cube is this, which is 225, right? So this way we are creating the x and the b matrices. Now once we have created these values, this is 56, this is 231, and this is 1013. Okay, this is actually the b, and this matrix, this represents x. Now first we have to find out the transpose of x, and this x transpose we can get like this, and these are the values that you can see here, which I already have calculated. And then finally I have to multiply this x transpose with the value of b, and finally I will get the value of a, and this a is nothing but consists of different coefficient values for me. So I can see that for b0 I'm going to have the value of 1.8, for b1 I'm getting a value of 33.7, and for b2 I'm going to have a value of 0.91. And now we can formulate the regression equation like this. Y is equal to, it is B naught. So B naught value is 1.8 plus B1x. So B1 is 33.7x. Then B2 x square. So 0.91 x square. And this is my final polynomial regression equation. And now you can use this equation to find out the value of certain patterns which are already not present in your data set. So if I'm putting up value of x which was not previously in my data set, like for example, if I put x is equal to 7, which was not there originally in the data set, I can find out the corresponding y value from this equation. So this is all for today, and thank you very much.